So the topic of my talk will be mobile HTML5 game development, and the lead keyword will be design for performance. I started doing this presentation with the idea that I will focus on technical stuff. So I draw this map, things to consider when making a game. And I drew that there's the idea and the whole creative process behind it. Then there's the market we want to target the game. We need to have some technical constraints and we need to be aware of them. Especially when we're doing games with HTML5. Then this step that I added at the end, this green one actually, can I make a working POC that will satisfy the customer? If I can, then I can proceed with the technology and sit down to the coding part. But after I drew that, I realized that the most important and interesting part and the thing I learned during the last year was actually these three things. So getting to know the market, getting to know the technical constraints of the system you are working with, and doing the working POC of the game. So I currently work for two companies that make casual games. One is Gambly, they are a Dutch company, and one is Nudeta, and they are a French company. And Nudeta has 1 million players each month. Gambly has approximately half of that. And I asked them for statistics, why they are moving their games from Flash mainly to HTML5. And I asked them, why do you need me? So they said that they noticed that the movement on their sites from mobile devices is steadily increasing. Currently, Gambly has 32% of mobile on their site, and Nudeta has 38% of mobile. So they realized that mobile is not only gaining traction in HTML5 gaming, it's becoming an important part of their revenue. And they had to do something with that, and the fastest model for them was to go into HTML5 games. And actually, as I work with those companies for over a year now, they have problems finding developers because they find a lot of people who can do the coding stuff part and the idea part, but they have difficulties delivering the games for different devices. Okay, and yeah, this is the bit migration. So they want bye-bye Flash completely and want to switch to HTML5 because mobile devices don't support Flash in the browser, and we know about that. Okay, so the first question is, when I started working with Gambly at first, can we do this with HTML5? So I created a straightforward segmentation for the big desktop, small desktop like these small laptops, I forgot how they're called, and tablets, and phones. So the big desktop, it hasn't any problems. Most of even all computers can handle HTML5 in the browser, and it doesn't matter if it's 2D or it's WebGL enabled, it just works. Small desktop tablets, things are getting edgy there. So you have, for example, iOS with the iPad. I'm not talking about iPad 1, but from iPad 2 and above, things just work, even though WebGL is only available for iOS 8 now. But I just installed it on the iPad 2, and the games just got smoother. So I went from 30 FPS to 60 FPS with no problem. And then we have Android, and especially the Galaxy Tab 3, which last week presented some interesting issues. Chromium got an update to their WebGL blacklist and setting algorithm, and Chrome pulled that, and it turned out that they disabled the chipset that is the GPU in most of the Galaxy Tab 3 devices. So suddenly all the games on the Galaxy Tab 3 went from 60 FPS to 20, 30 FPS. It's a pain they're fixing that, but we had to optimize some things to carry on with our development. And the most fragmented markets are the phone. And there are the most challenges you find here. And I'm not going to go in deep in the techniques that you must use, but most of the challenges are also design challenges. And I will talk about that later. So, okay, what technical hiccups can you encounter while developing for games for mobile? So, that's some of that 3D. So there are still devices with no proper hardware acceleration for the browser. The curious thing is that you can easily break WebGL on Galaxy Tab 2 and 3 devices on Android 4.1. And the screen will just go inverted and you will have a mess. So you need to force Canvas to de-rendering and do some crazy stuff there. And many people use these devices, unfortunately, so we need to support that. JavaScript is still a scripting language. It's just a scripting language. So it's fun to write, it's easy to write, but the processing performance isn't that great, even though V8 got many optimizations and all the JavaScript engines got many optimizations. And when you start doing things like physics, it's getting really weird and things can be very slow. And this can even happen on native wrappers. So for example, if you use Cocoon or Ejecta in the WebGL mode, then you can have 10,000 particles flying around and the GPU will take 2 milliseconds to render, but the CPU will be taking 30, 60 milliseconds to just calculate their positions and apply that. So we need to be aware of that and optimize our scripts as much as we can. Texture memory. This is another interesting topic because you can easily break, especially mobile Safari, when you try to load too much to it. And fortunately, which I learned lately, there are some nice optimizations beyond the export to web functionality of Photoshop that you can use to reduce that memory. Yes, and look under the canvas, because the canvas works, the thing you see isn't what the GPU sees. It's usually that, but the canvas has something that is called the batching store. And the batching store is different size on different devices. So you can have the pixel canvas, for example, 100 and 100 pixels wide, but on the iOS, for example, on the Retina devices, the batching store will be 200 by 200. So you need to take account textures into that. You need to take account your calculations to support this and normal devices. Okay. So when you start, you should test execution performance on different devices. So when you're developing your game, have a bunch of devices at your disposal where you deliver to the client. Because if you want, you will make a game which you are happy with, but bugs will start pouring at you, such as my Galaxy S2 is slow, S3 is fine, but S4 is slow again. Why? Because S4 has a device pixel ratio of 3, and those textures they use 9 times the memory as the normal browser, yeah, or the normal device. So do all the things in small iterations. Each component, each module you made, try to test it on as many devices as you can. If it's working and if it's reusable, put it somewhere. You will use it in the future for sure, and it will speed up the process you are making games. So this was the abstract common solutions part. And be a designer. So we know the terms like graceful degradation and progressive enhancement. Use that in game making. You don't always have to have thousands of particles or explosions on each device. Write a simple module that will test the canvas performance and work with that. Talk with the client about that. Mostly they will agree because they can be technical people also, yeah? So they just want their game to reach as many people as it can. And always try to think big. This is important. So when don't constrain yourself before the idea part is done. Do the idea first, and then try to work with what you have. You will push yourself to find new solutions and new possibilities with the code that you have at your disposal. Okay, so going back to the textures. So textures are so much more. The thing I do is I always segment the textures in my game by how complex they are. So I have simple textures that are a few colors only. I have textures that are little gradient, and I have textures that are full-blown gradient alpha transparencies, and they're horrible. And I segment them into separate sprite sheets because I can then compress them adequately. PNG allows you to actually reduce the size that you use for textures. So when you export from Photoshop, okay, the file is compressed, but it will always be RGBA 8888. So it means 8 bits for air, 8 bits for green, 8 bits for blue, and 8 bits for the alpha channel. And it's actually the memory on the GPU to process that texture. If you don't have any alpha, you can easily draw with RGB 888. You spend 8 bits per pixel that way, and reduce the texture size by 25%. If there isn't much gradient, you can go with RGB 565, for example. So reduce the number of bits per channel, and it will still be good. For alpha, it is the best I found in my work. I always try to talk with the designer or work with them so that I can use RGBA 5555 at most, and RGB 565 when the graphics is prepared properly in Illustrator or Photoshop. There isn't any visual difference between the bitmaps, and you save a ton of memory. Yeah, so the simple example is RGB 888 to RGB 4444. And it reduces the memory usage by half, so you can put twice as many textures on the device, or use twice less GPU memory, and the game will just speed up. And it's important here to be creative about what you can do and how you can segment this stuff, and work with the designer. Just not, okay, give me the assets, I will do something with them, because changing a simple gradient into Photoshop to have less banding or to go through a little amount of colors can make a huge difference in compressing the texture. Okay, so during game design, I learned one thing, and in development, that math is really important here. And if I knew that, but when I was in high school, I would pay more attention to it. But still, why is it important? You'll be able to communicate issues better. So you can explain a problem and really understand it to the customer. And in game development, I learned, or at least with the companies I work, they are almost all technical people. So if they understand the problem, they say, oh, okay, so you're right. So maybe we'll change the game mechanic a bit to avoid that bottleneck, yeah? The next advantage is you'll find many solutions to one problem. So you'll be able to optimize your algorithm, or at the base, so for example, your drawing algorithm, or your moving sprite algorithm, or your game loops. And it's in the regards to the JavaScript performance. The better your math is organized and optimized, the better performance you will have, and the less JavaScript will make you pay for your code. It will help you make game music. This is actually for the web audio API part. And the oscillator component. There are great examples of writing guitar simulators and stuff like that with only doing basic note math. So it's pretty awesome. You can pitch solutions optimal for the computer. So you can have a better solution for some devices and a better solution for the lower end when you need to do less things. You won't get stuck with a performance problem, because you can always communicate with the client and tell him, okay, we need to change this part of the physics system because it just won't work on the older devices. You can find solutions, what did I write? Faster, yeah. Because you know what you're looking for. So for example, if I'm looking for a solution to make game physics based on a circle, if I know the equations or the math problems that I need to solve, it's easier to find them and just even copy the algorithm, yeah, if I don't understand it fully. Yes, and your brain will store the best solution, so you will constantly learn. By skipping this math part, you are putting yourself in a dangerous situation when you get stuck in your development and you won't excel, and you can't make games then. Okay, so POC the word, so proof of concept. Do every project, engage with the customer and see if it's viable in the technology you want to do it. I always choose about 2 to 3 technologies depending on the market I want to target. So I put in my SDKs and I given myself 3 days to test the most important part of the game. So for example, the physics systems or some sprite behavior. And then I get back to the customer, so we can do this, but it will have these penalties. We can do Corona SDK, but it won't work in the browser, for example. I don't know how important that's for you, and so far and so on, and try to document it. This is the part I'm working on still, but you can then approach customers with a ready solution, and you can build them more easily because you know how much work you will have to do in that part. And then code, this is the most fun part of it. So you're risk-free almost because you did the POC, you did the research with your customers, you know your expectations, and so you can sit and code and be happy with the product that you have. Okay, and that's it. All right, do you have any questions? Yes.
So when working on the POC and then coding the game, do you work on your own, or are you part of the team with the customer? What is the process? Because they need some feedback loop, I guess.
Yes,
so there's
I'm always in contact with the customer. I'm always in contact with the team manager and the designer when I'm the only person coding. And if I'm a part of a larger team, then of course we're still in contact because we need to bounce ideas of each other, yeah? And as I said, closely working with the designer or the person that does graphics is very important because you can optimize a lot there. So for example, you can shift from sprite animations if you have big sprite to spine animation, the skeletal animation, and the other way. And you can very optimize the performance that way.
So I guess this is why POC is so important, because then you actually put a lot of effort into optimization.
Yeah.
So you don't want to change the requirements for the game, for example, right?
Yes.
Because it ruins a few weeks of work.
Yes, that's true. And you have, I take always 3 days, and I don't have that slip when, oh, but we need to support this, and I don't, yeah, it just works. Any more questions? All right, thank you.